Part 1, we looked at instruments which indicate pressure, temperature, flow, and fill level. We also need to know, especially during startup, what changes are taking place in and around the turbine. Just as a car may shimmy or vibrate at certain speeds, most turbines have one or more speeds at which rotary vibrations are strongly amplified. This is called a critical speed, and during startup, the turbine operator will avoid keeping the unit near its critical speed for any extended time. Turbine vibration is often recorded, indicating the magnitude of vibration at each main bearing, often also indicating turbine speed. Rate of rotation, very important in turbine operation, is usually monitored by a device called a tachometer. This generates electrical voltage or pulses which increase with rotating shaft speed. Usually, along with the device to measure and record the turbine speed, recorders or other instruments will indicate position of the main steam valves. Most materials, and especially metals, expand when they're heated. These electric wires are longer in hot weather and droop a bit more than they will when cold, and in large, closely fitted equipment, such as the steam turbine, expansion of heated inner elements can reduce the already close tolerances and endanger the entire machine as it rotates. Again, the operator has instruments to measure thermal expansion rates of equipment so he can prevent problems arising from excessively rapid startup or cool down. In addition to instruments which measure by dial, by signal, or by chart record, various temperatures, pressures, flow rates, etc. There are also a number of instruments which analyze. These devices tell us something about boiler water or combustion gas during operation. Let's look at combustion first. We know from a previous lesson that when fuel and air are brought together with heat, a chemical reaction called combustion or burning takes place. Separate the fuel from a good supply of air, the reaction will quickly stop due to lack of oxygen, as the candle has done in this picture. In a steam boiler, we want to supply enough combustion air to burn the fuel completely, so as not to waste fuel. On the other hand, too much air carries away heat wastefully. Examination or analysis of the exhaust gas means too much air is being used. A perforated tube called a probe samples hot flue gases into a cooling jacket and through some type of air pump. The sample is also filtered before it passes through the analyzer. This device examines the chemical content of exhaust gases, indicates, and in some cases records the oxygen content. Other devices may keep watch on the flame size and temperature using photocell devices which see flame temperatures by measuring ultraviolet or infrared light levels. Many units employ closed-circuit TV to observe flames within furnaces. Others use special detectors which warn the operator if the flame gets too large or too small. Correct, efficient combustion monitoring and control can easily save a plant several tons of fuel every hour. But along with proper burning of fuel, effective transfer of heat into boiler water is important. The water in these thousands of pipes must be free of dissolved materials, which can form hard-scale deposits inside boiler tubes. These thin crusts of minerals act as excellent insulators, blocking rapid heat transfer of the metal. At one time, most power plants had a chemical laboratory which made frequent tests on boiler water, feed water, and condensate to be certain water stayed as pure as possible. Today, most labs have given way to automatic analyzing instruments which continually sample, analyze, and indicate the chemical condition of water from several sampling points. The simplest of these are conductivity measuring cells. Here, steam samples are cooled and condensed to water. A special device measures the amount of electrical current which can be conducted through the condensate. Pure water is an excellent insulator and resists current flow. However, dissolved solids permit some current to flow. The more that can flow, the higher the percentage of dissolved material in the condensate. Now, since conductivity changes with temperature, most conductivity instruments are compensated for changes in sample temperature, or like this unit, they reheat the sample to maintain a constant cell temperature. It is also important to measure the pH of the condensate. pH metering devices measure the amount of acidity, or its opposite, alkalinity, of solution by means of probes or electrodes. The pH meter reads degree of acidity or alkalinity on a scale where a reading of 7 is neutral. to keep the water and steam from changing pH rapidly, and to slow down the action of water in trying to dissolve copper and iron from the pipes. Modern analyzers are able to detect the presence of minute traces of dissolved materials in the boiler steam system. Measurements, often as small as parts per billion, are determined by colorimetric analyzers. Here, a special solution called a reagent is mixed with the condensate sample. If the material to be detected is present, a reaction produces a different color in the solution sample. A system of photocells and special optics permit the colorimetric analyzer to detect very slight color changes that a human eye would not at all be able to notice. The automatic analyzer correlates intensity of color with the amount of chemicals in the sample and shows it on a meter or recorder. This continuous sampling and analyzing gives the operator rapid notice of sudden changes. Whether it's a complex colorimetric analyzer or a simple pressure gauge, the information these instruments provide is extremely important. Like a fine watch, the instruments used in the power plant should be treated with care. If they are misused, they may become inaccurate. An incorrect instrument may not let us know the situation until it's too late to properly make changes. Good instrument maintenance coupled with proper usage will give the operator the kind of reliable information he needs. If an instrument or analyzer does not seem to be correct, be sure the trouble's in the instrument and not in the system itself. The operator should use his instruments and not permit the instruments to run the plant. He can think and make decisions. Instruments can only help. Okay, page 28 again has some thinking and decision making for you to do. When you finish the quiz on cartridge number 2, restart the machine and we'll check your answers together. If you answered question number 1 false, you were correct. Critical speeds when turbine vibrations are strongest are speeds to be avoided. Number 2 is true. Uneven heating of the heavy metal part in the turbine can be caused both by starting or stopping the unit too rapidly. The amount of oxygen in the flue gas is usually used as the indicator of correct combustion, not the hydrogen. 3 is false. Fuel, not heat. 5 should be marked true. Analysis of boiler feed water is important to preventing heat transfer reductions caused by scale and slime in the tubes. Pure water lacks dissolved ions needed to conduct electrons, so 6 is true. 7 is also true. Colorimetric analysis uses the color change caused by a reagent in a feedwater sample. It does not rely on the color, if any, of the impurity itself. But these color changes can be so clear and the instrument so sensitive that they can detect minute traces by this means. So number 8 is true. A pH meter tells the degree of acidity or alkalinity in a solution, nothing more. So the answer to 9 should be false. And of course, our final answer is true. Reliable instruments require proper maintenance, and certainly they should be used and interpreted correctly. It's part of a good operator's job. Well, this completes the discussion on instrumentation.